Okay. Hello. Well, hello. Okay. Good evening. I am Saurabh, and I welcome you to this live session for the NPTEL course Applied Thermodynamics. In these live sessions, we solve some problems. We try to solve some doubts which you can have during lectures. And since these are live sessions, so we try to take some live questions from students in the chat box, or maybe you can unmute yourself and ask whatever doubts you have. Okay. So this course name is Applied Thermodynamics. As the name suggests that this course is the applied one. This is not the basic one. So I hope that you are familiar with the basic thermodynamic concepts. If you are not, then I request you to please go through basic thermodynamic courses, or you can take help from any standard textbook like Sinzel. Okay. So this is a 12-week course, and each week one module is covered. In the first week, the module 1, which is the review of basic thermodynamics, this is covered in the first week. Okay. So in today's session, we will try to solve some problems which are related to the lectures of week 1. Okay. So they will be related to the basic thermodynamics. Okay. So they will be like just a revision of basic thermodynamics. Okay. So let us begin. Okay. So here's the first question. It says that in a closed system, the energy can cross the boundaries in the form of only heat transfer, only enthalpy transfer, only heat and work transfer, and last one is the only work transfer. Okay. So before you proceed, you should know what is meant by a closed system. Okay. As I said, that you should be familiar with the basic concepts, some basic terminology. Okay. So a closed system is a system in which mass transfer cannot take place, but energy transfer or work transfer, these transfers can take place. Okay. So in a closed system, energy can cross the boundaries in the form of heat and work. Okay. This is just a definition of closed system. Okay. So the correct option should be part C. Okay. Question number 2. It says in an isobaric expansion of gas. Okay, so isobaric means a process where the pressure does not change. Okay, pressure is constant. Isobaric means constant pressure. Okay. In such expansion where the pressure is constant, what will happen? Options are volume and temperature both increases, volume and temperature both decreases, volume increases but temperature decreases, and volume increases but temperature also increases, both increases. Okay. So if you just apply the PV is equal to nRT from this equation itself, you can answer the question. Okay. Here it is saying that pressure is constant because it is isobaric process, and expansion means volume is increasing. Okay, expansion means volume is increasing. So P is constant, but volume is increasing. This N is constant, R is constant, so T should also increase, right? So volume and temperature both should increase. Okay. volume and temperature both increases. But last part also is the same. Okay, so both are correct. Mistakenly, both options are same. I hope this is clear. Okay, so we can move to the next question. Question number 3. It says, which of the following argument is true in thermodynamics? First argument is work is path independent function. Second is work is path dependent. Third is work is defined by area under PV curve. And fourth one is work and energy are completely interchangeable. So we have to tell that how many of these arguments are true. Okay, which one is true and which one is not true. So let us check one by one. So argument one, it is saying work is path dependent function. So is it true or false? Work is path independent function. So it is not correct. Okay, because work is path dependent function, right? We know that work is path dependent. There are some functions which are not path dependent. They are just point functions. Those functions we call property. Okay, point functions. But work is a path dependent function. Okay. So second option, second argument is correct. Third one is that work is defined by area under PV curve. This is also correct. PV curve is something like this. P is pressure and V is volume. And this curve can be representation of a process. Like from point A to point B, this area under this curve will be this area. Okay. From mathematics, you know how to calculate this area. This area is calculated using integration, right? Integration will be P dV integration from point A to B. Okay. And P dV, you know, this is work, right? P dV is differential work, right? So if you integrate this del V from A to B, you will get the work done, correct? Okay. So area under PV curve gives the work. Okay. So third argument is also correct. Fourth one says that work and energy are completely interchangeable. Here, energy means heat. Okay. If you are confused by this term energy, let us use the term heat. Okay. Actually, it is heat, not the energy. So fourth option says work and heat are completely interchangeable. So is that correct? This is not correct because we know that work is an organized form of energy. Okay. It is high grade energy, you can say. Work can be completely changed into heat, but heat cannot be changed completely into work, right? This is what the second law of thermodynamics says, right? Okay. So work can be completely interchanged to heat, but heat cannot be completely converted into work. Okay. So the fourth one is not correct because this violates the second law of thermodynamics. So only second and third arguments are correct. So the correct option should be part A. Okay. Second and third. Okay. I think this is clear and we can move to the next question if you have no doubt. Okay. Let us move to the next question. Question number 4. It says that which thermodynamic concept provides the useful measure of quality of energy? Okay, quality of energy. In the previous question, we have discussed that work can be completely converted into heat, but heat cannot be completely converted into work. Why? Because heat is a low grade energy and work is high grade energy. Okay, so the quality comes into the picture. Okay, energy has quality. High quality energy can be completely converted into low grade or low quality energy, but low quality energy cannot be converted into high quality energy completely. There will be some loss. Okay, so which is that thermodynamic concept which provides this measure of quality? This is related to second law of thermodynamics. So is it entropy, exergy, or energy? It is exergy. Okay, so exergy is actually the measurement of work potential. Okay, so it is like maximum work which can be extracted from a given system at a given state in a given environment. Okay, so the correct option should be exergy. It is related to entropy, but since only one option is correct, so the exergy should be the correct one. Okay, so let us move to the next question. Question number 5. Question number 5 says the entropy generation associated with the closed system is not a thermodynamic property. Okay, let us try to understand this question. What it says, it is saying something about entropy generation. So I hope you remember what was entropy generation. Entropy is a property. Okay, it is a point function. It is a fixed value at some given conditions. But entropy generation, this is a uh, like path dependent function. Okay, entropy generation is related to some process. Okay, entropy is generated in all the irreversible processes. Okay, entropy generation is defined for a process, so it should be a path function. Okay, and the path functions are not the properties, because the property, when we say thermodynamic property, it should be a point function. So the entropy generation cannot be a point function. It is not a thermodynamic property. Okay, so the statement that it is not a property is a correct statement. Okay, so the answer should be true, right? Because entropy generation is not a thermodynamic property. It is a property of path, or we should say it is a path function. And when the entropy generation is positive, it is positive for or irreversible processes. For reversible processes, it is zero. Okay, so the process will be either reversible or irreversible. So the entropy generation will be either zero or positive. It cannot be negative. Okay, so I think we can move for the next question. Question 6. It says the heat given to an ideal gas in isothermal conditions is used to do external work. Heat given to an ideal gas. Ideal gas means the gas which follows the ideal gas equation, PV is equal to nRT. Okay. In an isothermal condition, isothermal means that temperature remains constant throughout the process. Okay. Isothermal means constant temperature. And constant temperature means there is no change in internal energy, right? Because internal energy is the function of temperature only. So constant temperature means no change in internal energy. So delta U will be 0. Okay. Now heat given to an ideal gas in isothermal conditions is used to do external work. So if you use the first law of thermodynamics, which is del Q is equal to del W plus del U, this is the first law of thermodynamics. Here delta U is 0. Okay, delta U is 0 because it is an isothermal process. So whatever heat is provided to the system, that will be used to produce some external work. Okay, so del Q will be equal to del W. Okay, so it is a true statement, right? So it is true. It is just use of first law of thermodynamics, energy conservation. So if this is clear, then we should move to the next question. Okay. Question 7. It says, if a system is undergoing thermodynamic change when Q is equal to 0 and W is equal to 0, or when Q is equal to W, the process can be called as, here Q is heat transfer and W is work transfer. Okay. So let us analyze this process. It is saying Q is equal to 0. That means there is no heat transfer. Okay. And when there is no heat transfer, those type of processes are called adiabatic processes, right? And W is equal to 0 means that there is no work involved. Okay. So from the first law, that we discussed in the previous question, the internal energy change should also be 0. Okay. But again, it says, or when Q is equal to W, means if W and Q are not 0, but heat transfer is equal to the work produced, then what will happen? Then what will happen? Just use the first law of thermodynamics, del Q is equal to del W plus delta U. Since Q and W are equal, so both will cancel out each other. So we will get delta U is equal to 0. So this means it is a process where internal energy of system is constant. And when internal energy is constant, that means temperature should be constant. Okay. So what are the options? Let us see. First one is constant enthalpy process. No. Actually, the first one can also be correct one, because enthalpy is defined as U plus PV. Okay. Delta U is not changing. U is constant. V is constant. If we assume this system to be a simple compressible system, then work will be given by PdV, and work is 0, then volume will not change, right? But the pressure can change, right? So enthalpy will not be constant. Okay. So the first one is not the correct option. Second option says constant internal energy process. Yes, it is correct. As we have found here, delta U is equal to 0. Okay. Third one says constant volume process. If the work done is 0 and the system is simple compressible system, then volume will be constant. But if it is not simple compressible system, some other type of works are involved, like shaft work or some other work, or when delta W is not, when work is not 0, then volume can change. Okay. And last part, constant pressure process. So this is also not the correct one. Okay, we cannot conclude that volume will be constant or change. We can only conclude that internal energy is constant in this process. Okay, so the only correct option is part B. Okay, so I think we can move to the next question. Question 8. It says, what will happen to the temperature of air coming out of a punctured football? Okay, so there is a football and it is punctured. Punctured means there is some hole and air is coming out. So what will happen to the temperature of this air? What will happen to the temperature of this air? If we consider a small part of this air which is coming out, a small mass of air, if you consider, then what will happen to this part of air? It is expanding, right? Because inside the football, pressure was more, and outside the football, pressure was less, right? It will have to be lesser pressure outside. Because of that only, the air will come out. Okay. So when air comes out of the football, then what will happen? It will expand because the pressure outside is less. Okay. So it is expanding. And if you assume that this process is happening at quite high speed and there is not sufficient time for air to get some heat from outside, then we can assume that this process is some sort of adiabatic process. Okay. There can be some heat transfer, but that heat transfer can be very, very negligible, right? Because it is happening at very high speed and there will not be sufficient time for the heat transfer. So so what will happen? There is no heat transfer if you assume, and there is expansion. So what will happen? From the first law of thermodynamics, we can write del Q is equal to del W plus delta U. Heat transfer, if it is negligible, then delta W. Okay, delta W here is positive. Why? Because there is expansion. Expansion means positive work. Okay, expansion means positive work done by the system. Here, system is that small part of air. Okay, so this del W is positive, and sum of del W plus delta U is 0. So delta U will have to be negative, right? Delta U will have to be negative. Why? Because del W is positive. Okay. So since delta U is negative, this means internal energy is decreasing. And internal energy is the function of temperature only. So this means temperature should decrease. Okay. Temperature should decrease. So what are the options? Option A says it will become hotter. No, it is wrong. Option B says no change. This is also wrong. Option C says it will become cooler. This is the correct one, right? Because temperature is decreasing. Okay. The air which is coming out from this punctured football, that will become cooler. Okay. The sudden expansion of a gas that uh, that produces a cooling effect. Okay. So if there is no problem, then we can move to the next question. Question number 9. It says that for an spontaneous process, choose the correct option from the following expressions for the entropy of system and surrounding. Okay, so delta S system is the change in entropy of system, and delta S of surrounding is the change in entropy of surrounding. Okay. And then is a sorry, and spontaneous process means a process which is happening spontaneously, means it does not require any trigger or any external support. It is happening by itself. So these type of processes usually occur when there is free energy generation, or the system tend to achieve a more thermodynamically stable state. But anyways, that is not required even to answer this question. Option 1 says entropy change of system minus entropy change of surrounding, it will be positive. Option B says that entropy change of surrounding will be positive. Option C says that entropy change of system plus entropy change of surrounding will be positive. And last option says that entropy change of system will be, you know, uh, positive. So which one of these is correct? I think everyone can easily answer this question. Many times we will encounter this statement that entropy always increases. So entropy always increases is basically in context of an isolated system. So if you add system and surrounding, that will form a isolated system, right? That will be system plus surrounding becomes universe, right? And universe can be assumed to be an isolated system. So the entropy of universe always increases. Okay. So the entropy change of system plus entropy change of surrounding, that will always be positive. Okay. So option C should be correct. If we see other options, like the last one, that entropy change of system is always positive. No, it is not. Okay. You can have the processes where the entropy can change be negative for the system. Like there can be some exothermic reactions where entropy change can be negative for the system. Okay. Or when there is heat rejection from the system. But in those cases, the entropy generation due to the irreversibility, that should not be very high. Otherwise, if the entropy generation is very high, and that entropy generation, if that dominates the entropy reduction due to the heat rejection, then again the whole entropy change can become positive. Okay. So the entropy change of system plus entropy change of surrounding, that will always be positive. Okay. For system alone, it can be positive or negative. For surrounding alone, it can be positive or negative. But if you combine both system and surrounding, then the entropy change will be positive only. Okay. Positive or zero. If everything is reversible, process is both internally as well as externally reversible, then entropy change can be zero. Okay, so it will be either zero or positive. So the third option is the correct one. Okay. So if there is no doubt, then we can move to the next question. Question 10. Question 10 says, a simple compressible closed system initially at a specified state point receives a specific quantity of heat while undergoing a reversible process. Among the following possible processes, which one will correspond to the largest change in the internal energy? So the simple compressible system, right? Closed system means there is no mass transfer, only heat or work transfer. Okay. It receives a specific quantity of heat. Okay. So del Q is positive. It is receiving some heat. And it is going a reversible process. Okay. So the entropy generation is, zero. And for reversible processes, you can write work del W is equal to PdV. For reversible, simple compressible systems, you can write del W is equal to PdV. Okay. So this is the information that is given in the question. Now we have to tell which process will have the which will correspond to the largest change in the internal energy. Internal energy change is delta U. Okay, so the first one is reversible isobaric process. Isobaric means P is equal to constant. If, let us see one by one each option. Isobaric means P is constant pressure. Okay. So for constant pressure, if you write, then it will be del Q is equal to del W plus PdV. Okay. Next process is isochoric. Isochoric means constant volume. So dV will be 0. Okay. So del W will be 0. So del Q will be equal to, sorry, uh, here in the first part, there will be plus delta U. Okay. Isochoric process means volume is constant. So delta V is 0. That means del W is 0. So the whole heat that is transferred to the system, that will be utilized to increase the internal energy. Okay. Third part is isothermal. Isothermal means temperature is constant. And constant temperature means internal energy will not change. Okay. So delta U will be 0. And last one is isentropic. Isentropic means entropy is constant. And since it is reversible isentropic, so this means it is an adiabatic process, right? So in adiabatic process, delta Q will be 0. Okay. So now we have to tell that among each processes, in which process there will be maximum change in internal energy. Okay. So all the information we have. The first one is isobaric process. So here pressure is constant. So delta Q is going into both parts in doing work as well as increasing the internal energy. In the second part, the whole heat that is transferred to the system, all of that heat is utilized to increase the internal energy. In third part, internal energy not changing at all. Okay. And the last part is there is no heat transfer. Okay. But in the question itself, it was given that there is some, heat given to the system. So we have to consider only first three options. In the first part, since heat is divided into two parts. So delta U, this can be changed. This can be positive. Internal energy can be increased, but it will not, receive the maximum portion of, delta Q, because some part of del Q will be wasted into PdV. Okay. In the second part, whole del Q is going into delta U. Okay. So in the second part, there will be maximum change in internal energy. In the third part, internal energy is not changing at all. Okay. So the isochoric process, in this process, there will be maximum change in internal energy. Okay. Isochoric. because there is no work done, and whatever is given as heat, all of that heat will be converted into internal energy and temperature will be increased. Okay. If there is no doubt, then we can move to the next question. Just read this question and we will solve this. Okay. So question 11 says a heat engine receives heat at a rate of 2 kilowatt from a reservoir that is maintained at 1000 Kelvin and rejects 1 kilowatt to another reservoir that is maintained at 300 Kelvin. If the engine produces 1.2 kilowatt of power, then which one of these options is correct one? Okay, it is receiving 2 kilowatt. It is receiving 2 kilowatt from a reservoir that is at 1000 Kelvin. 2 kilowatt it is receiving, and it is rejecting 1.2 kilowatt at 300 Kelvin sink. Okay, this is your system, let us say. So the remaining work, it can be the remaining heat, this, can be converted into work, right? So point one can be the work production, 10 kilowatt. Okay. So it can satisfy the first law. Okay. So option A, which says that it satisfies both first law and second law of thermodynamics. So the first law is satisfied, but we are not sure about the second law. For the second law, what we'll have to do? We'll have to calculate the efficiency. What can be the maximum efficiency? And maximum efficiency is given by the Carnot principle, right? So if you try to calculate the Carnot efficiency for this, for this, so how will we calculate Carnot efficiency? It's given by 1 minus TL by TH, correct? So 1 minus 300 divided by 1000. So 1 minus 0.3 or 0.7, right? So this is the maximum efficiency which we can have if everything is reversible. Okay. So the work production, the maximum work production will be the maximum efficiency into heat received. Okay. So 0.7 multiplied by 2. So the maximum work production can be 1.4. Okay. But in this question, the maximum power that we are getting is 0.8. Sorry, this is not the 0.8. We have made a little mistake. In the question itself, it is giving that it is producing 1.2 kilowatt of power. Okay. So we are getting 1.8 kilowatt. Okay. So 1.8, sorry, 1.2 we are getting. Okay. So 1.2 that is given, that is not the heat rejection. That is the production, power production. Okay. So we are getting 1.2 kilowatt as work output, and the remaining part will be the heat rejection. So 0.8 kilowatt can be the heat rejection. Okay. So anyway, it satisfies the first law. So we were trying to check the second law. Okay. The maximum work production can be 1.4 kilowatt, but here we are getting only 1.2 kilowatt. So it can satisfy the second law. Okay. So part one says it satisfies both the first law and second law. So first law is obviously satisfied, but second law can be satisfied. So second part says that it satisfies the first law of thermodynamics, but violates the second law. No, it does not violate it. right? Because we are not getting the maximum work, we are getting some lesser work output. Third option says that it satisfies the second law of thermodynamics, but violates the first law. No, it is not violating the first law. Last part says it violates both first law and second law. No, it is not the. It is also not the correct one. So it satisfies both first law as well as second law. Okay. So this is the correct option. Part A is the correct option. Okay. So I think everything is clear and we can move to the next question if you have no doubt. Question 12, it says, on a hot summer day, a student turns his fan on when he leaves his room in the morning. When he returns in the evening, what will be the room temperature? Assuming all the doors and windows are kept closed. So in a hot summer day, a student turns his fan on. Okay. When he leaves his room in the morning and evening he returns, then what will be the temperature? And we have to assume that all the doors and I'm sorry, our meeting was stopped because there was some network interruption. So I will solve the remaining questions and I will merge, merge this recording with the recording of our meeting and I will upload the merged video in the YouTube. Okay, so we were discussing the question number 12. Okay, so question number 12 says, on a hot summer day, a student turns his fan on when he leaves his room in the morning. When he returns in the evening, what will be the room's temperature? Assume all the doors and windows are kept closed. Okay, so it is given that we have to assume that all the doors and windows are kept closed. So what does this basically means is that we have to assume that there is no heat loss from the room. Okay, even if the doors and windows are closed, there can be heat loss, but let us assume that there is no heat loss. Okay, assumption, no heat loss. All the walls and windows are perfectly insulated. Okay, now this is his room. Okay, there is one fan and everything is perfectly insulated. There is no heat transfer, okay, because of insulation. So del Q is 0. But del W, it is not 0. Why? Because there is fan. Okay, so there is some work being done on the system. If you assume the air inside the room to be system, then there is some work that is being done on the system. This is electric work or soft work, whatever you want to call it. Okay, so delta W, this is negative, some negative value because it is being done on the system. So what will be delta U? From the first law of thermodynamics, you can write it as del W plus delta U is equal to 0. Okay, so delta U will be minus del W, and del W is negative. So delta U, this will be positive. Okay. So internal energy will increase. Okay. Energy is increasing. That means the temperature will increase. Okay. So the room will become warmer. Okay. It's just a simple logic that because there is no heat loss to the surrounding, and electricity is coming inside the room, and that electric energy will be anyway will be dissipated into heat. Okay, so that heat will increase the temperature of the room. Okay, so the room will become warmer. Okay, so we can move to the next question. Question number 13. It is saying that iced water means frozen water substance. We have to tell that whether this statement is true or false. So iced water means the frozen water. Water is basically H2O. Okay, it does not matter whether it is frozen or it is not frozen, whether it is liquid or ice. Water is simply H2O. Okay, so when there is only one compound, then we call that it is a pure substance. Okay, when the chemical composition is fixed, then we call it as pure substance. Only one chemical, or you can say fixed composition. Then we call it as pure substance. Okay. Another case you can take, there is some liquid water and there is some ice. Then whether this mixture will be pure substance or not, still this mixture will be a pure substance. Why? Because there is only water. Some water is in the solid state and some water is in the liquid state. But still it is only one compound. Okay, so it is a pure substance. So the statement is true. Okay, all the compounds are pure substances. Question number 14. It says that a person is cooking some food for his family in a pan. That is, there is few cases. Case number one is that pan is uncovered. Second one is that pan is covered with a light lid, and last one is that pan is covered with a heavy lid. So for which one, for which case the cooking time will be shortest? Okay, so there are three cases. Number one, pan is uncovered. Number two, pan is covered with a light lid, and the last case, pan is covered with a heavy lid. Okay, so what will happen if the pan is not covered? So the pressure just above the pan will be equal to the atmospheric pressure. Okay, this is the pan and this is burner. If it is not covered, so the pressure here will be equal to atmospheric pressure. But if it is covered, then what will happen? The pressure inside this pan, it will start increasing. Okay, and we know that the boiling temperature, it depends on the pressure. If pressure increases, then boiling temperature will increase. Okay, boiling temperature, it is the function of pressure. Okay, boiling temperature is nothing but saturation temperature at some given pressure. Okay, so it is function of pressure at a given pressure. For saturation pressure, the saturation temperature is fixed. If you increase the pressure, the saturation temperature or the boiling temperature, that will increase. So what will happen if you increase the pressure? The saturation pressure will increase. So the water will not boil. Okay, the water will not boil means that you will get more
heat for the cooking of food. Okay, if the water start boiling at very less temperature, then there will not be enough heat transfer for the cooking of the food. Okay, so increase in the boiling temperature, that gives you an opportunity for the heat transfer to the food. Okay, so the food will be cooked more easily. Okay, so when it is not covered, it will take more time. When it is covered, it will take lesser time. And light lid means there can be some pressure leakage. Okay, and heavy lid means there will be very less pressure leakage, so there will be more pressure buildup. Okay, so when the pan is covered with a heavy lid, in that case cooking time will be less. Okay, so the part C should be the correct option. Okay, so once again I am repeating, saturation temperature or boiling temperature depends on the pressure. If pressure is more, then the boiling temperature will be more. And when boiling temperature will be more, then it will boil after a delay. Okay, so you will get so there will be better chances of heat transfer. Okay, so cooking time should be less. So we will move to the next question. Question number 15. It says that there is a 600 megawatt steam power plant which is cooled by a nearby which is cooled by a nearby river that has thermal efficiency of 40%. Okay, so this steam power plant has a thermal efficiency of 40%. We have to tell the rate of heat transfer to the river. Okay, so let us say this steam power plant is getting some heat, let us say Q in. Okay, and it will reject some heat to the river Q out. Okay, to the river, and the difference of Q in minus Q out, that will be your okay rate of power production. So this is given as 600 megawatt, and efficiency is defined as this rate of power production divided by the heat input rate. Okay, so 600 megawatt divided by rate of heat input, that is equal to 40%. Okay, so from here you can tell what will be the Q input, rate of heat input. So that will be equal to 600 megawatt divided by 0.4. Okay, we have to tell what we have to find. We have to find the heat transfer to the river water. Okay, so heat transfer to the river water means heat rejection. Okay, so we have to tell Q out. Okay, rate of heat rejection to the river. So this will be equal to what? This will be equal to Q rate of heat input minus rate of power production. Okay, so 600 megawatt divided by 0.4 minus 600 megawatt. Okay, so this you can easily calculate. Okay, there are few options, but anyways, let us calculate this. So it is 900, right? 900 megawatt. Okay, so option A, 900 megawatt should be the correct option. I hope this is clear, and we can move to the next question. Question 16. It says, does the difference in enthalpy of saturated vapor and saturated liquid change with pressure? Answer is yes. If you check this saturation curve, you can check it, and or any steam table you can check, then there you will find that this difference in enthalpy of saturated vapor and saturated liquid, this depends on pressure. Okay, so you can check any TS diagram or any diagram, or whether or you can check enthalpy entropy diagrams. Enthalpy entropy diagrams are known as Moliere charts. Okay, so any of these you can check. So on TS diagram, if you make a isobar means a constant pressure line, it will look something like this. Okay, it will look something like this green line. Okay, so this point 1 is liquid, saturated liquid. Okay, this saturated liquid will have some enthalpy. Let us call this as HF, means enthalpy of fluid. And this point 2, okay, this point 2, this is saturated vapor. Okay, so let us say enthalpy of saturated vapor is Hg. Then this difference of Hg minus Hf, this we call Hfg. Okay, so this difference depends on the pressure. Okay, if you make some other isobar, then you will get some other points. Okay, then this Hfg will change. Okay, so this thing depends on pressure. Okay, so option A should be correct. Okay, or you can check Moliere charts. Moliere chart are basically enthalpy entropy charts. Okay, so question number 17, it says that exergy is some blank space on the amount of work a device can deliver without violating the laws of thermodynamics. So it is just definition of exergy. So exergy is lower limit of the work, or it is upper limit of the work, or minimum amount of the work which a device can deliver without violating the laws of thermodynamics. So if you have watched the lecture, then you should be able to answer that. Answer should be, it is the maximum amount of work that a device can deliver without the violating the laws of thermodynamics. Okay, so upper limit. Okay, just a definition based question. So we can move to the next question. Question number 18. It says, based on entropy principle, the entropy of universe, it always increases, or it always decreases, or it remains constant. Okay, so from second law of thermodynamics, you know that entropy of a isolated system, it will be positive or zero. Okay, it cannot decrease. In the isolated system, if all the processes are completely reversible, then the entropy generation will be 0, otherwise it will be positive. Okay, so universe can be considered to be an isolated system. Okay, we can say that universe is not interacting with any, any other universe. So universe is like a isolated system, and since the entropy of a isolated system always increases, so the entropy of universe should also increase. Okay, it cannot decrease. So option A should be correct option. If everything inside the universe was reversible, completely reversible, then the entropy can be, constant. But there are some processes, that are irreversible. Okay, so overall entropy of the universe, that should increase. Okay, question number, it was question number 18. We can move to the question number 19. The performance of an engineering system is degraded by the presence of irreversibilities. Correct. And what is the measure of the magnitude of irreversibility present during the system? Sorry, during the process. Whether it is exergy or entropy or entropy generation or none of the above. Okay, so I hope you must have guessed that it should be entropy generation. Okay, entropy generation is the measure of the irreversibility of a process. More irreversible means more entropy generation, and if the process is completely reversible, then entropy generation is 0. Okay, so the entropy generation is the measure of irreversibility present during the process. Okay, and if the process is reversible, then we say that system is, working in the best mode. Okay, but because there are some irreversibilities are always there in the real life, so we do not get the best performance. Okay, question number 20, it says a refrigerator in a refrigerator, heat is transferred from a lower temperature medium, that is refrigerated space, to a higher temperature one, that is the kitchen air. So it is asking, eh, this is a violation of second law of thermodynamics. Second law of thermodynamics says that you cannot transfer heat from a colder space to a hotter space without any external work. Okay, but in the refrigerator, that heat is transferred from a lower temperature medium to a higher temperature zone, but there is external work. That external work is done by the compressor of the refrigerator. Okay, if you see the back side of your refrigerator, then there will be, you see some black box type of thing. Inside that black box there is a compressor. Okay, so that compressor uses some electricity, and with the and then it do some work, compression work, and because of that work only, this heat can be transferred from the lower temperature medium to the higher temperature medium. Okay, so the refrigerator does not violate the second law of thermodynamics. Actually nothing can violate any law. Okay, if any law is violated, then it is not a law, right? Law means there is no violation. Okay, so all the devices which you see or use, so always the laws of thermodynamics of or any law of physics, law should be satisfied. Okay, if you imagine something that violates the first law of thermodynamics, then you call that device to be a perpetual motion of first kind. And if you can imagine a device which can violate the second law of thermodynamics, then you call this as perpetual motion of second kind. But in reality, perpetual machines does not exist. Okay, so the laws are always satisfied. That's why they are called laws. Okay, so this is false. Okay, okay. Question number 21. It says, among the following statements, which one is the false for a closed system undergoing an irreversible process? Okay, there is a closed system and there is some irreversible process going on. So entropy always increases during a heating process. Okay, entropy always decreases during a cooling process. Its entropy can decrease or increase during a cooling process depending on the magnitude of heat transfer involved. Its entropy always increases during a adiabatic process. Okay, let us see all these options one by one. It is a closed system. Okay, it is a closed system. So in the closed system, heat transfer can take place. Okay, if it is not adiabatic, then heat transfer can take place. If heat is added to this closed system, then there will be some entropy transfer to the system because of the heat transfer. Okay, so entropy transfer due to the heat transfer. Okay, this will be positive. Okay, because heat is being transferred to the system, and there is some irreversible process going on, so there will be some entropy generation. Okay, so this positive heat transfer plus the positive entropy generation, so that sum of these, the total of these two quantities will be positive. Okay, so the entropy will increase. Okay, so the first statement is true. Second statement, its entropy always decreases during a cooling process. During a cooling process, the heat will be rejected. Okay, so entropy will also, reduce because of the heat rejection. But there is some irreversible process going on, so because of irreversibility, the entropy will be generated. Okay, so this entropy rejection plus entropy generation, the total of this can be either positive or negative. Okay, depending on how much the process is irreversible. Okay, if there is very less heat, is very less entropy is going out as a result of heat rejection, but a lot of entropy generated because of large irreversibility, then this quantity, the entropy change can be positive. Okay, and in another scenario it can be negative as well. Okay, so the part B, which says that it always decreases, this is not correct. Okay, so this is false. And part C says that it can decrease or increase depending on the magnitude of heat transfer involved. Yes, this is correct. Okay, depending on the magnitude of heat transfer and irreversibility, uh, entropy can decrease or increase, or it can even remain constant. Okay, so part C is true. And part D says that entropy always increasing during an adiabatic process. Yes, this is also correct. Okay, because during an adiabatic process, there is no heat transfer. Okay, so the entropy change associated with heat transfer is zero, but there is an irreversible process going on. So because of that irreversible process, there will be a positive entropy generation. Okay, so the total, the sum of two quantities will be positive. Okay, so entropy will increase during an irreversible adiabatic process. So part D is also true. Only part B is false. Okay, so we had to tell the which one is the false. Okay, so part B is the false. Okay, so I hope this is clear, and we can move to the next question. Question 22. It says a system is maintained at a temperature lower than its immediate surrounding temperature. Its exergy is positive, negative, zero, or undefined. Okay. If the temperature of a system was greater than the surrounding temperature, then we know that exergy is positive. But what about the case when temperature of the system is lower than the surrounding? Will the exergy negative or positive? In this case also, exergy will be positive. Why? Because there is some potential difference. Okay, your system can work as a sink. You can take some heat from the surrounding, you can reject some part of that heat to your system, and you can generate some work. Okay, so there is some potential for the work generation. Okay, so exergy is basically that representation of that work potential. Okay, so whenever there is some temperature difference, there will be some exergy. So exergy cannot be negative, it is always positive. Okay, so part A is correct. Okay, I hope this is clear, and we are moving to the next question. Question number 23. It says that irreversibility for a heat pump can be defined as heat pump. What is a heat pump? What does heat pump do? Heat pump actually takes some heat from a colder environment, and it rejects heat to a hotter environment, and obviously with the help of some external work. Okay, so let us say this is a cold environment. So heat pump will take some heat in, and there will be some work input, and it will reject heat to a hot environment. Q out. Q out will be equal to Q in plus W in. Okay, so this is that work that is being asked in this question. If everything was perfectly reversible, then we will call this work as reversible work. But if there is some irreversibility involved, then work will be more. Okay, we will have to put more work, right? Then what will happen? We have to tell that irreversibility involved. Irreversibility involved means how much extra work we are putting in. Okay, so useful work means that actual work. Okay, so useful work minus reversible work. Okay, so this is extra work you are putting in. So this is the representation of irreversibility involved. Okay, so the part B should be the correct option. Okay, so whenever there is irreversibilities involved, then for a work consuming device you will have to put more work. Okay, and work producing device, they will produce less work whenever there is irreversibility involved. And this difference between the reversible work and the actual work, that is the representation of how much irreversibilities are involved. Okay, so I hope this is clear. So this was the last question. Okay, so I will merge this recording with the recording of our meeting, and I will upload the merged video in the YouTube. Okay, so again, I'm sorry for the inconvenience because of network interruption. Okay, thank you.